Updated the content of this week. So on Monday, we went over the logical functions, data validation, lookups. We're going to just continue with match and index. And you know what? And then we'll go over the time value of money. But second thought, I'll start with time value of money functions, and then we'll go back to match index. Yes?
I have one question. So we have that VLOOKUP and HLOOKUP. Now that is when we have a fixed list and we have an identifier. Say the first one is a serial key, and then we can say change the order in the second list. But is there any function where we can change the order of the entire list based upon the first list?
So you want to do a lookup. The VLOOKUP basically forces you, the premise there is that the value you're looking for has to be in the very first column. If you want it, if there's a different case where you need to look up, let's say, the column in the middle of on the right, and you need to return the value to the left of that column, this is where you use match index. A combination of these two columns. We're going to see that. For a lot of people that I've seen, basically, if the order is not really critical, a lot of them rearrange the data, put that first column, and just be done with it. Because match index, it's basically two functions, you combine them into one. We'll see that later. Okay. Okay. So again, who's in finance and accounting? Okay, half the class, good. So this is right into your ballpark. Okay, so just quick look at the syllabus. So we've seen already, we are today week 3, class 5. Going over the financial functions. As I mentioned, we'll go back to the lookup functions and match index. Next week, just a reminder, we'll be in the lab. And we'll work, it's going to be hands-on practice on linking external worksheets. And Wednesday is off, so it's one class next week. Yes?
You can use our own system.
I prefer that you use the computer in the lab. For one reason, because this is where you're going to be doing the midterm. So I want you to get used to what we have in class and in the lab. Yes.
Like for the exams and stuff, or even on the homework, are you looking for like specific functions? Like if you want us to use them, you'll tell us. Otherwise, we can kind of do things how we want. Say something for like
that's exactly it. If I want you to use a specific functions to get something done, I'll specify that. Mm-hmm. Otherwise, whatever you use is good. As long as you get the right answer, you get it working, that should be fine. Okay. And toward the end of the class, also, we're going to a little bit go over homework. Gonna pick the lucky 2 tonight. So you notice it wasn't really that hard, just straightforward. So just as I mentioned, this to warm you guys up. Okay. So let's get started with the time value of money. All of you or most of you had some kind of loan where you pay back with some interest over some period of time. Could be as simple as credit card, could be a home loan, could be a car loan, could be a student loan for some of you. So how does that formula work? What decides how much you pay? So this is the theory and the formulas about the payments value and future value and so on. And this is true for a loan you made, you got and you paying back, or an investment you put in, so where you put money in and you're expecting return. So the difference between a loan and investment is the direction of the cash flow. When you get a loan, it's money in, it's positive, and then you pay it back. So every payment is a negative cash flow, goes out of your money bucket, your account. The investment is the opposite. The initial amount is out, it's a negative cash flow. You put investment in, and then you start receiving payments. The simplest one, if you buy bonds, say treasury bonds or any kind of bonds. You buy an investment and you expect a monthly payment until the whole deal is out. So we're going to look into this. It's going to make a difference. You need to know when you're going to put a negative sign before the formula or not, because it is an inflow or outflow. There's a couple of terms we need to familiarize with. Let me just zoom in a little bit. So these are some of the Excel terminology. So I have a payment. There's a PMT function. This is not all Excel, but this is basically the symbol of the formula, and it matches what's in Excel. So we start with the present value. You get a loan, $10,000. That's the present value. Why do we have to worry about present value and future value? Interest rate / inflation. So $1,000 in 1980 is different than $1,000 today. So if you look at any historical data, let's say S&P, oil prices, you always see a note at the bottom, prices adjusted to like current year. Give you an example. How much is, for example, an average or like the salary of a government employee? Let's say manager of post office. How much would that be? I don't know, 50, 60, 70, $80,000. The average salary of a government employee in 1928 was $3,000, the dollars of that time. So that gave you how much the money was inflated. So keep that in mind. Every time you hear a dollar amount, long time ago, you have to adjust for that. At some point, the U.S. had a coin that's half a penny, and it was worth something. So that's the present value and the future value. So present value is how much it is right now. Let's say I get a loan, $10,000. I need to pay it until it hits a value of a future value. Ideally, to pay it off, future value has to be 0. So we need to pay it with a certain rate, interest rate, at a certain frequency until it hits 0 or until it hits 1,000, whatever that future value is. And then we make payments based on number of periods. Is it a monthly? Is it weekly? Is it twice a month? Is it once per quarter? Is it semi-annual? Whatever that period is. And how much the interest per that period. These two have always to match, and many people make a mistake. The interest rate will be provided annually, and the payment is monthly. So you have to divide the interest rate by 12, because that will be the interest rate per month. The interest rate has to match the period. And this is going to be on every single homework and every single exam. Because kind of a standard, the interest rate always annual, regardless what's the payment term. So always need to think about that. And there is one optional element, is if I go to the bank and get a loan right now, when is my first payment due? Let's say it's a monthly. Typically, the end is a month later after I get the loan. But there are some options, basically, the first payment due at the beginning of the month. This is where the K kicks in. So it's 1, basically, if it's the end of the period, or 1 plus the interest rate if it's at the beginning. And Excel will have a parameter for that. Okay. So these are the values we're looking for. All these determine what is the payment. So you need the payment, think about it as the output. This is the payment calculator. So what do we have as input? We have the present value. We have the interest rate. We have the number of periods. And optional, we have future value, unless it's 0, which is by default, and the payment at the beginning of the month, or the end of, or the beginning of the period, or the end of the period. So we need to provide these to get that. And this is the formula, basically, where you put all these in: present value, future value, interest rate, period, and the payment is due at the beginning or the end of the month. So Excel has a function that does this, and we'll see how we'll use it. So I'm not going to go through everything in this page. There's a lot of examples. I'll leave it to you guys to have the fun. And basically, if you're missing any element here, you can retrieve it from the others. So by default, or the most common is you need to get the payment known everything. But sometimes you know the payments, but you need to know how much will be the interest rate, or how many periods, or what would be the future value, and so on. So all these, basically, the formulas of this page will give you the formula of each value, how you get it from the others. This is how you get the future value. This is how you get the present value, number of periods, and so on. So Excel has a matching function for each one of these. And all collectively, these are known as the time value of money functions. And to be for the Excel specific ones, these are the ones. We have the PMT, rate, number of period, present value, future value. So this is also on Blackboard, that link. You go over it. Okay. So let's get started with, one more note on the side. Homeworks, before I forget. I specified in the instruction of the homework how you're gonna name the file. Some of them missed it. I'm a little bit picky when it comes to these details. So don't use the workbook, just use exactly as I mentioned. HW1, homework 1, dash, no spaces before after the dash, and your name. The reason is it's gonna take me more time to correct that, put in that formula that way, because I open them one after the other. And because when I grade them, I have you guys listed alphabetically. So I go one by one. And any file that's not in the right place is gonna messes me up. Okay. And this also will get you used to something called naming conventions. A lot of you use that at work. Some departments are very strict about having naming convention because how the files are organized. So just pay a little bit more details to that. And no submissions by email. I made one exception this time and last one. It's your duty to upload it via Blackboard and to make sure it's uploaded right. All of you. So let's get started. This is, this one. So loan payment. This is very basic example. So you have a loan of $300,000. Let's say it's a house. And the annual rate is 8.5% over 30 years. And you expect at the end of 30 years period to pay it off completely. So how much would be your payment? So first, the payment is monthly, or let's say it's monthly payment. Payment term is monthly. So number of payments, how much? 30 times 12. So let's see how we're going to calculate the payments. Equals PMT. The first parameter, can you guys read it? Okay. Rate, what's the rate? Divide by 12. Number of periods? 360. Present value? 300. You notice future value and type, they're between square brackets. Means if you don't provide them, future value is assumed to be 0. This time we're gonna put it. And this is the type, payment type. Is the end of the period or the beginning of the period? By default is the end of the period, so I'm not gonna enter it. Of course, wrong parenthesis. So your monthly payment is $2,306. And why is it in red? And let's change this type from currency to general. You notice it's negative because it's outflow. Now let's say the final balance will be $20,000. You notice it goes down, or hold on. Final balance 2306, control. So your payment goes up slightly. Oh, because after 30 years, $20,000 don't forget, this is $20,000 after 30 years. So to bring that back to the present value is actually much less. So you're not saving anything. So this is how much the payment. This includes what? The loan payment includes what two elements? Principal and interest. So this is a loan, positive inflow, negative outflow. Let's look at investment. It's kind of the opposite. Same formula. So you invest $100,000 in a market fund with 5.4 annual interest rate, compounded monthly. To know how much, okay, there's some typo in here. You would have to add to this fund each month so that the value of the fund will reach 300,000 18 months from now. So you put money. The initial money will automatically get interest on top of it, right? But that wouldn't be enough to reach 300,000. And you committed to put monthly payment on top the initial investment. So in 18 months, you will that fund will hit $300,000. How much do you need to pay to put in every month? So your investment plus the interest you're getting every month will to reach 300,000. With the same function. So what's the rate? Divided by 12 because it's compounded monthly. Number of periods, 18 periods. Present value, 100,000. Future value, 300,000. So you need to add $21,000. Hold on, something off here. No, it doesn't add up. Hold on. Annual interest compounded monthly.
When you make the contribution?
Making the end of the month. Number of period 18. Yes. That's the one. You put $10,000. So 10,000 times 18, that's almost 180 plus 110. So you put almost $280,000 of your own money, and those will earn you almost $220,000 of interest during that period. So this will add up to $300,000. Okay. The other way to do it is use this as negative because this is also outflow, so you don't have to use the negative here. So this is initial investment. Let me put it this way. 100,000 is going to be 300. So your payment will be $10,000. If you want to wait longer, that will give the interest more time to accumulate. If you want to give it, let's say, 54 months, then you'll pay less per month. But so your total payment will be plus, instead of 280, you'll be paying 250. So there'll be more contribution from the interest because you're allowing more time for the interest to accumulate. Any questions so far? Okay. So I'm gonna jump just to the interest. Actually, let's go back here. So we said this will be the total of the interest payment and the principal. So how much will be the interest payment? What's it called? The interest payment is IPMT. Actually, you know what? Leave that to the amortization schedule. Let's go future value. So future value, you want to know if you put an investment with a specific interest rate and a monthly payment top of that and a specific period of number of periods, how much you will get at the end of that period. So let's say you put $100,000 and at 5.54, and simply the payment could be zero. I don't want to pay anything, but just tell me how much would that be end of 18 period. So we'll get to that. So we'll use the future value function. So the rate, as we mentioned, always annual divided by 12. Number of periods is 18. Present value, because its outflow is negative. The payment, because its payment is outflow, 7,500. Present value is $100,000. So if you put $100,000 and every month you put on top of that 7,500, in 18 months your account will be $248,000. If you don't pay a penny, you'll get only $8,000 on top of that.
Why were the last two inputs negative?
Because it's outflow. This is the money you put in. You take it out of your account, you put it in that investment account. So the loan is a positive flow. Somebody pay you money, so it's inbound, inflow. When you pay out, when you make the payment for the loan, these are negative. But this is investment, so you take investment, you take the cash out of your checking account, put in your saving account. Let's say you lock it there. And on top of that, you keep adding every month. And as the money is there, it's earning interest. So you want to know if you put initially 100,000 and you commit to put 7,500 or let's say 2,500 every month, how much your account will be after 18 months? How much you expect to see in your saving account if the interest is compounded monthly? Now, a different way to look at the problem, you want to know how long it's going to take you to pay a certain loan, or how long it's going to take for your investment fund to reach certain value with certain interest rate. So with an interest rate of 5.4% and with a payment of $7,500 and initial value of present value of 100,000, you want to reach, your goal is, your target is $300,000. How long is going to take for this account using these parameters to reach this value? So use the NPER function, which is number of periods. Same thing, you provide the rate, payment, because you paid out, that's negative, the present value, which is negative 100,000, and the future value is $300,000. That will take, how are we going to read this number? 24 months. Because it's not going to be like 3 weeks through the last month you're going to get that. So you need to round that up. It's not 23, it's 23.01, it's 24. So this is how you know how long either your investment is going to reach a certain goal or how long it's going to take you to pay a loan. You notice with the loans, this is some credit cards that get you locked in with interest rate, basically high interest rate. So I was listening to the podcast the other day about loan sharks in some states. Basically, legally they have no limits. They can go. There are some of them like they charge as much as 500% per week. Those like what they call it payday loan sharks. People looking to get $500 for like a week or 2 weeks, 3 weeks, and they pay way more than that on just interest. So you think, just $500, but nobody reads the terms and conditions. Nobody knows how to do the math for how long it's going to take them to do that. Yes?
What if the compounding is different than the payment terms?
You need to adjust those.
Okay.
For example, The compounding. Okay, so let's say this is compounding quarterly, and the payment is monthly. What would be the formula here? Divided by 4. So whatever rate is, you have it, you need to divide it by, has to match the payment. Again, present value. Now you need to look, for example, if you have a fund available to you at this rate, 5.4, for only 18 months, and you know you can put a monthly payment of 7,500, but you say, you know what, I wanted to reach 300,000. How much do I have to make initial payment? How much do I need to pay upfront to do that? Same thing applies if you say you want to buy a house. You need to put a down payment. That down payment will impact your monthly payment. You want to buy a house at this rate, and everybody knows this is kind of more of a common sense. The more you put a down payment, the less you pay monthly, and overall the less interest you pay. Because you pay interest on the money you're gonna borrow, not the money you pay upfront. Ideally, if you can pay the whole thing in cash, it'd be better. So we'll use PV function. They're almost all the same. You have the rate, number of periods, which is in B9, 18, the monthly payment, or payment per period, in this case is monthly, 7,500, and future value of 300,000. That means my initial investment has to be $147,000. So, and again, all these functions, these parameters, you'll see that they match exactly what these functions here. Let's say present value. These are the inputs to these formulas. You have two choices. Either you do it on paper or use that function. Now that will make you appreciate actually the bankers back in the days before computers and calculators. They used to do all this by hand. So don't complain about your job, if you have one. I know some of you don't because you're full-time students. I don't mean to be sensitive. I mean, when I was a student, I wish actually I could quit my job and just focus on school, but it didn't work that way. Okay, any question on these? Okay, the rate I'm gonna just skip through quickly. Come on. Okay. So the rate, same principle. We need to find the rate if I have 18 months of payment and I know how much I'm gonna pay per month. I know how much my present value, initial investment, and what's the goal. So what the rate should be, minimum at least, to get to that goal. And again, the interest rate, the rate will give you the interest per period. Keep that in mind. So if this is a monthly, this will give you the interest per month. So you need to provide number of periods, the payments, present value, and future value. Okay, and then you multiply that by 12. That's 23% rate. So before the I payment,
Professor?
yes.
Within the rate function, if the payments are being made quarterly,
Then you multiply, if you want the annual rate, then you multiply that by 4. Yes. Because think about it from the opposite. If you were provided the rate, you have to divide that by 4. Okay. For this one, actually, I'll go to another file to look at. But let's take this loan example quickly. You have a loan of $100,000. The annual rate 5.4. You know what? Let's change the number. Let's put it 8. over 24 months. So the monthly payment is, you divide the rate by 12, provide all other functions, and that will give you a monthly payment $4,500. Now, how much total you'll be paying after 24 months? It's simply your monthly payment times 24. So you borrowed $100,000, but you paid back $108,000. What would be the interest out of that? This is the total interest, will be simply the difference. But now we're gonna look at the amortization schedule. Let's say you have this $100,000 and you're gonna pay payment. So you wanna know at every statement, every month, from your payments, how much you're paying principal, how much interest, how much is the remaining balance. Because if you look at any bank statement or credit card statement, they will say the beginning balance, this is how much you spent, this is how much you paid, and this is how much the balance is left. I'm going to do a little bit more of a combination of things we've learned. So this is the loan amount, $300,000 over 6 years, compounded weekly or whatever. We have this reference table, we'll use it in a bit. And that if it's paid weekly over 6 years, how much would be the payment? The payment per year? 52. Therefore, the number of payments will be what? 6 times, oops, equals 6 times 52, 312. Okay, let's just take a step back before we start putting formulas in here. Let's name these. This is loan amount, right? And this is number of payments. This is, leave that, I don't need as input. This is interest rate per period. This is annual interest rate. Okay, now let me do this. I know these are my option for the payment terms: semi-annual, quarterly, monthly, semi-monthly, and weekly. So we can use data validation. Change this to a list. So now I can simply pick, and then I'll use the VLOOKUP function. Based on monthly, I know monthly means 12 payments per year, right? So I'll do VLOOKUP of this value, find it here, table 2. We'll get to tables later. Hold on. L7, 4. And need to return the second column, and has to be an exact match, correct? So this makes my life a little bit easier. Let's say it's monthly, or let's say monthly. So number of payments equals, hold on, need to name this, number of years. This is payment per year. So number of payments equals, see, the moment I select this, it's going to put the name. So when you look at the formula, you can read it. Times what? So it's number of years times payment per years. So if I go back to calculate, first the interest is equals to what? Annual interest rate divided by payments per year. Now let's calculate the payments. Equals PMT. What's the rate? Interest rate per period. Number of periods is what? Number of payments. Present value. Actually, let's make this, leave it. And future value is 0, of course. This is negative. So to make this number positive, you either put a negative before the formula, or you can put the present value, the loan amount, as negative. Either way is correct. So this is your monthly payment. This doesn't change. So what would be the total payments? So monthly payments times what? Oh, hold on, I didn't mention this. This is payment per period. So the total payment equals how much you're going to pay per period of payment times total number of payments. So you borrow 30, you pay back 34,000. Therefore, total interest equals total payments minus whatever you borrowed. Now, let's look at monthly. At the end of every month, the initial balance is what? Was the loan amount, right? And the payment is always this payment. Now, this we need to break it up. So, PMT is actually, PPMT is the principal plus the interest. And these are the functions. Now, since the payment every month is the same, is that true for the principal and interest?
No.
So then you'd expect to specify for which period you're trying to get the principal payments and the interest payment. So it's PPMT. The rate is the same always, rate per period. Now we need to specify for which period you need to look at. And this comes from which line? This is period number 1. Out of how many periods? 72. And what's the present value? And let's put this into negative. So out of 483, only 358 is the interest, is the principal. Now, interest payment based on this, in this scenario, you have two ways to do it. Either the difference between these two, or you simply use the IPMT functions. I'll be a little bit lazy here because they have the exactly same parameters. Let's use this to I, but let's verify that. So the rate, period, number of periods, and payment. And to validate our numbers, let's sum these up. 483.15. That's the payment. They should add up. They must add up to the monthly payment. If they don't, there's something wrong. In every period, interest plus principal has to add up to the total payment. This is how you check. Now, what's the ending balance? So $30,000. You made your first payment, 483. How much is left to pay? Minus what? Minus the principal, not the payment. So the ending balance of the first month is actually the beginning balance of the second month, or the second period, correct? Okay. So we'll highlight these. Do the same. So next month you pay 483, out of which 359 is the principal, 123.51 is the interest rate. You sum them up, same thing, 483.15. So as you notice, as you make more payments, the principal portion is going to go up, the interest portion is going to go down. It's not fixed. And we expect that after 72 months, the remaining balance should be what? 0. So after you do this, if after 72, let's see, do we have 72 here? Yeah. If the remaining balance, ending balance on is not 0, means something is wrong with your formula. So for every month, every payment period, you will know how much you're paying, how much of that is principal, how much is interest, and how much is left. So you know 72 after 6 years, end of 3 years, which is what? 36 months. After 36 months, on a $30,000 loan, you'll have $16,000 left if you don't make any extra payments. Okay. So we have this chart for you to show you the principal and interest change. So the blue part is the principal, and the red part is the interest. So in the first period, you know, good chunk is interest, remaining is principal, and that diminishes. Who benefits from this model this way? Bank. They make, where they make the money? The interest. So they make most of it before, like by half, they already made 2/3 of the money. And this is the ending balance, how it starts from, the ending balance actually against this axis. Start with 30,000, goes down to 0. This, we'll get to charting, but this is simply a stacked area for both interest and principal, and a line for the third data. So we have 3 series. So if I click on the red, it highlights which one that is. This is the interest, this is the principal, and this is the ending balance. So if you notice, for every period, they all add up to the same value. This is your monthly payment. Your monthly payment doesn't change. But the component, the breakdown of that payment change. How much is interest, how much is principal. Okay. Because the ending balance basically is impacted by the principal. How much you make. It doesn't deduct the interest. Yes?
I have a question about naming cells. Like, so if you wanted to delete a name from a cell,
Yes.
can you do that?
Yes, you go to formula, you have something called name manager. These are the names I just entered. You can simply select it, you can point it to another cell, you can edit it, you can change the name if you made a typo, or you can simply delete it, which actually I'm going to do with this. I'll change it later. So, yeah, under name manager, you can manage all the names.
Delete it. What is that going to do to all the formulas that you've used it? Is it going to leave it?
Good point. Let's try that. Loan amount. Delete. Okay. Yep. Loan amount is not defined anymore. The problem is, can we undo it? Yes. Worst case, I'll just type it back in. But yeah, if you delete it, I'm not sure actually if you rename it. Loan amount 1. I think we're gonna have to do the same. No, actually, it does update. If you rename it, it does update, so you don't need to change anything. So let's say you don't want to go through the whole schedule just to find a specific interest payment, how much you're going to pay interest specific period. So we can use the IPMT. In this case, let's say payment number 10. We use IPMT. Rate, again, this is rate per period. Period number 10. Total number of periods 72. And present value 30. Interest will be 111. Let's check. Number 10, yes, 111.34. We can do principal also paid. can use the same function, except this is PMT and this is still F8. The total sum, no, total only of these two. This will be your total payment, and this should match this. So any period you want, put it let's say 50. There'll be 44 in interest and 439. Can put negative. By the way, the shortcut, if you don't want to use the mouse to edit a cell, is F2. And that applies to even Windows. Let's say you want to rename a file, also F2. Same thing. So this is a Windows shortcut rather than just Excel. This would be. Any question on these so far? We're good? Should I ask for a volunteer? Will do. So let's see how the interest changes compared to the total interest. So the total interest is $4,000. So if we add all these, it'll add up to 4,786. Let's add a sum value up here. So the sum. This is total principal. We drag this sideways. And this should also add, so this total of these two, 34, should be added up to this, and this works. So let's see, as we pay, how much the cumulative interest is. I want to know, let's say after the 10th period, how much total interest I paid. Is that 20% of the total interest, or how much? So how can I find how much is interest? Let's take randomly this one. How can I calculate the interest of what have I paid interest so far out of the total? So it'll be the sum of, this is the total interest I paid, correct? Out of how much? You can either use the number down here or the formula here, both the same. And let me put this as F4, because always I need to reference G3. Also, to make things a little bit more interesting, let's get a percentage of this out of number total of payments. So when you're 10% through, you already paid 17% of total interest. But let's fix the form a little bit. Something is missing. If I want to move this up or do down, I need this always to start here. What do I need to change? Which one? E15. Let's try it. It's working. So let's do the same here. Here I don't have to do it because I'm referencing the name, number of payment. So it's automatically absolute reference. So you pay 25% of the total interest, just 15% through the payment, the loan time. And you expect, of course, at the end to be 100%. So the bank gets 50% of the loan, only a little bit less than third through the third of the total loan time. So out of the $4,000, they get $2,000 before you even hit the middle of the loan. And they hit the 75% mark. So halfway through, they already got 3/4. I said first 2/3 of, obviously I was a little bit optimistic. So that's why the bank, they don't care much if you default toward the end of the loan, because they already got most of their money. If you default at the beginning, then yes, they're screwed. But yeah, past the 50% mark, they already made 3/4. Okay. And you can do that mathematically. Let's see. I'm not going to do it, but just a little bit of geometry. Let's draw. Let me use the touch point. So if I want to maximize this a little bit. The reason I want to mention that because for one simple reason. This is the type of chart area stack. So the total of the interest is actually represented by the area of this triangle. And same thing with the principal. So basically what I want to say, if you have a vertical line going from left to right, at one point that vertical line will be 50% of the total area. That's how you solve algebraic. And in this case, as we said, 50% is going to be at the third. Hold on, when we said 50%, yeah. So at 31% between here and here, this area already 50% of the total, which is, of course, is not half because it's not a rectangle. So because it's left heavy, at 30%, you already cut that triangle in half. Okay. Any question on this? Good. Okay. So I'm going to ask a volunteer to come up here and rebuild it. Delete. Come on. Any volunteer, or should I volunteer somebody? Come on, guys. No. And you guys can also change the values. Doesn't really matter. Okay. So. You put the beginning balance, payment.
Rate will be our interest rate per period.
Okay.
Then
what's next?
Number of payments.
Which period are we looking at?
Okay, one.
First period.
NPR,
Because you can help him if he gets stuck.
NPR is 12.
You're all gonna be in this position at some point, so.
PV will be this. Then FV is 0.
You don't need it. Still negative. Oh. So the value should be positive, should read positive.
Okay, yes. Loan amount.
Yeah, you can do it this way or the other way. Ending balance is what? Actually, I put it up here. I should have put that.
Then this one will be.
You notice in this case, you don't just put the first line and you replicate it. You need to put the second line first, and then you replicate the second line. You get 0 at the bottom? The ending balance is it 0? Yes, that's good. So, thank you. So as I mentioned, you have 2 checkpoints here. First, you need to always check that the total of principal and interest adds up to the payment. If it doesn't, one of the 3 is wrong. And the last remaining balance should be 0 or whatever future value you set there if it's not 0 at the end of the period. Is it clear? Are you all gonna go back and check your credit card statement? See how you're getting ripped off? The reason it is good actually to have this type of financial analysis because in your life, you have multiple credit cards. You have balance on all of them. If you follow this or you dig a little bit deeper, you can decide which one to pay off first. Because your goal is to reduce the interest. So in overall on a high level, you start with the one you pay more interest on. But there are, actually I wanted to mention that when you open a new Excel, you notice there are templates here. A lot of these are useful. I'm not sure if any of you guys had looked at these. You have cash flow analysis. It's a template's already there. You have even a calendar. You have inventory list. You have a student calendar. I never use myself. You have personal expenses calculator. There's really a lot of cool templates already there. Just click it, it's there, put your information, and boom, get a dashboard there. You have family budget. It's monthly. A friend of mine, actually, she's CPA. She uses QuickBook for her family finances because she wants to track what they're spending money on what. She puts in everything, like how much they paid on grocery, gas, insurance, everything. So, but she's an accountant too. So, okay. Any question on these? Good. So let's go back to homework 1 and let's volunteer 2 of you. Okay, so between 1 and 30, let's do a quick random. We'll hit it a couple of times. Let's see, hold on, who's 29? This is just a try. Okay, let's do a couple of times. Guys, say stop. 26, who's 26? Yan Lu. Is Yan Lu here? Oh. Here you go, come up here. So let's check your homework. I haven't graded all of them yet, so you should get your grades by, shouldn't be later than Friday. Yes, you get the grade and you'll get the solution on Blackboard. So, Jan, do you want to come up here, just explain to the class what you did? Stage is yours. So first question, if I remember, let's do quick cosmetic. We need to total and average. So how you did the total and average, the one in yellow?
The total is the sum of the whole year.
Okay, that's B7 to M7. Okay, that applies to all of them.
Yeah.
It's good. And the average is
the average of the whole year.
Okay. And the same thing you did for the month, average and sum. Okay, so this is the first one. The second, I assume, is the same.
Yeah.
Okay. Now, let's see here. Units sold. First, the abbreviation. So, how did you come up with this? So, we need the first 2 letters abbreviation of the country.
Use the upper function is to make the all letters capitalized.
Okay.
And in the upper function, use the left and select the
8-1 is this country, that's
Yeah.
fine. You can use this list or the other list, so it doesn't matter. Okay. So you notice what she did here. She first used the left function. So this will return the first 2 letters of the input value, which is 820, that's the first country. And that will, in turn, that output of the left function becomes the input of the upper function. That will force it to capitalize. Let's say you want to do the opposite. Let's say we want a lowercase. What do we use? Lower. And if you want just the first letter to be capitalized, proper. Add this to your dictionary. Let's use 4 letters. Of lower, upper, and proper. So all caps, all lowercase, or initial cap. Good. So let's see, total of 2014. So this number is from units sold from where? Total of Australia, 3556. Okay, see, here's the trick. Now this should be a formula, not static. I know you did probably copy paste values, but this should be length. Simply should read M7. Reason is, let's say you made a mistake, somebody came to you and was like, you know what, we made a mistake here, is actually 310, it's not 288, it should automatically reflect here. If you copy the value, you lose that connection. And the change is the difference, correct? And change percentage is, why isn't it the difference over 2015? Right, this by definition, the change is new minus old over old. Okay. The revenue is 375 times B4, correct, which is, go through these, this is C34, correct? Change, same thing. Okay, good, thank you. So you're going to see similar example, either going to be for homework, probably going to be part of the next homework. Similar thing, but with basically you have the sales in different currency. So you get the units sold are units sold, but the price, instead of having a 375 US dollars flat, you're going to have the unit price per the local currency with the exchange rate. In 2014 and 2015, and then you have to convert everything to dollars and show the dollar figures, because that when in real life that will be the real life scenario. If you sell in different countries, most times you sell in the local currency. There's some places you always can sell in US dollars, but just take US and Euro. Now, American companies who they sell in euro, they're happy now. The euro went up from, I think, 108 to 120, 121. That means the same amount of euro now means more US dollars. They got this extra money by doing nothing, just because it happens in euro. But also this double-edged sword, to be the opposite. So we'll see that example later. It's going to be a part of the next homework. Then you see sometimes, like year to year, the sales of unit increases, but because of currency fluctuation, the dollar amount goes down. Yes?
If you want to link vertical to horizontal, like the monthly totals, first chart, if you want to link that in the second chart vertically, how do we do that?
That I'll get back to you next time on it. Just remind me. There is a quick way to do it. It's escaped me right now because I rarely use it. I need to do something on that, but it can be done.
You just transpose it, but if you want to link
it transpose it, but it's not the link. It doesn't link it. If it's just a few things, it's just like you do them manually, but there is a way to do that by a formula.
Wouldn't you just keep the 15 static, like equal to that cell, if I'm understanding the question right?
So basically, he wants these values to be linked, but he wants them vertical. So let's say he wants
so just equal that cell and then just keep the 15 static, no?
No, but you want to drag it down. But as you drag it down, you want the one below to refer to the cell next to it, to the right. So he wants this to be transposed, but at the same time keep it linked. Okay. Any question on this? Okay. Okay, let's quickly go to the match indexed. So the match function, you need the lookup value, lookup array. Let's use to insert, add a few more columns here. So just let's start with match function. Lookup value is what the high school. Looking up where? Here. And always absolute reference. We're going to want exact match. Hold on. Match lookup value. Oh, sorry. I meant to use the index first. So we'll use the second variation of index. The reference is E2. And phone number. The match. Lookup value. This should be the one. Let's give an NA.
Because you should select only column N. Yeah,
Oh yeah.
take that to the-
Sorry, you're right. This should be enough. Not N2, this should be this. This column has to be absolute. Okay, so this is what tells me match returns the position of the first match of this value in this reference list. So this tells me in that list is position 1. Grad is should gives me position 3, and it isn't. What am I missing here? Don't think it has to do with this, but yes, okay. So the match returns a number. You provide a value, the match function will check it against the list, and it tells you where in that list the first match exists. And then that will feed into another function called index. Then you'll use that index. The index function is the opposite. You provide the index a list. I was like, here's the list, give me the value, let's say in the 10th row, on the 10th position, then it will return the value of that cell. So I'm going to use it just as a test here. In this array, I need to return what's in position 2. Tell me it's undergrad. So, but instead of me specifying 2, I'll use the 2, which is the output of the match. So the match will feed into the index. If you want to visualize it. So the match function, you provide the lookup value. and the reference list. The ref list gives you the position of that value in that list, which is a number, or we're going to call it index. Now the index function, you need to provide a position in the list, and the output is a value. The value of that index in that list. So this works exactly like the lookup. So if I use index of what array? This array. Hold on, and we need to get this score, right? So equals index of this array will be the match, yes. Now the row, which row? This one. V1. So column H and F should match. And we can check that by doing a quick subtraction. Should always be 0. So I mean they match. So here's what happened. Let's say hide, leave that. So the match function returned what? Told me, the match function told me what's the index of that value of the education level. Let's take the first one, or the second one, grad. Grad is position what? 1, 2, 3, 4. Then I took the 4, I retrieved what's at position 4 of the second list. That's the matching score. The difference between this and lookup is that the score could be to the left of the initial lookup value and it will still work. For the lookup function, the score has to be always to the right of the initial value to look up. So if I make a copy of this, I can use this for the index. Hold on, let me put the whole function in. And instead of O2, I need this to be here. Let me hide these two. So now I find what's the position of high school on the first list. It's position 1. I feed that 1 into the index function, and I ask index, give me the value of the score at the first position because it matches the other list. So the score could be the left to the right, doesn't really matter. So anytime you need to do a lookup where the returned value is to the left of the lookup value, you need to use match index. If it's to the left, then you can use VLOOKUP. So in this case, if this is how you have your data, you cannot use VLOOKUP based on the text. You cannot provide undergrad and expect VLOOKUP to give you 2 if the return value is to the left. Only if it's to the right. Other than that, we can just use VLOOKUP. Yes?
How does it know that it needs to look up score? Is it just the first one that it's looking at? Like in VLOOKUP, right, we'll tell it, okay, count columns to 7, and that's what I need.
So that's a combination of 2 functions. Let's say you need to look up graduate, right? So then to return where this value is on this list, you use the match function.
Okay.
So you say, take grad and look up this list and give me where is it? So it'll tell you, it's the 3rd row.
Okay.
Now you know that's already 3rd row. Then you need to provide that number 3, the 3rd row, to the second list. I was like, based on that value, give me what's the value on the score on the 3rd row. So then the index will return, providing this list and the 3rd row on this list, give me the value of that score and tell you, it's number 3. Now you know it's matching because you're passing the output of one becomes the input of the other one.
Just kind of like
Correct. Yes, Alina.
take the left or the right or any.
Doesn't matter. It doesn't know left or right. It's just the index.
What if there's different numbers?
Right.
Which one would it take?
Which mean different numbers.
If the left and the right.
So if the score, for example, this could be 5, 6, 7, and no, basically these two lists, they should match in length because you do want to look up. So every value here should match a value here. So let's say if these are the values, so graduate, the VLOOKUP will give you what? You pass grad, it will match the second column, return 7, correct? Okay. The match index, let's hide this. So the match part of this, what we're doing, we're feeding grad into the match function. So I'm telling the match function, go over this list, look for grad, tell me where it is. It will return a value of 3 because it's the third, correct? Then that 3 now becomes the input to the index. Now I go to the index function. I was like, index, please look on this list and give me what's in position 3. Because it matches what you found earlier. Give me what's in position 3, it returns 7.
So you would just highlight the column that you needed to match to within that position. So if like I have 7 rows to the left or whatever, you'll just highlight column A, whatever it may be.
Right. You can highlight more than one column, so match index, because if you notice, you can highlight an area actually. If you only highlight one column, you only specify that column, so it's 02 to 05. But if you highlight area, you can specify which column you wanted the value to return from. But you only can return one value, so you need to specify which column if you highlight more than one column. Correct. Oh, we're 5 minutes over, sorry. We'll give it to you next time.